Okay, second of four problems here in problem set 44, homework set 44. This is a sister to number 24, problem 23, page 669. Very similar to the previous problem. We're given some data. We're asked to find the equation and graph it. So let's just kind of graphically get down what we were given. We're told that there are 2 points here. They are foci. This one right here is 5, 0. This one on the other side is minus 5, 0. So already we realize that we're dealing with the two branches of the hyperbola opening left and right. And that means, by the way, that we're dealing with the form that says x squared divided by a squared minus y squared divided by b squared is equal to 1. And in this case, the asymptotes are y is equal to plus or minus b over ax. In the previous example, we had the lobes of the branches of the hyperbola opening up and down. We wrote that y squared over a squared minus x squared over b squared is equal to 1. The asymptotes were plus or minus b over a. And most importantly, you know, what you're always going to need is this kind of additional relationship. And it always says, if you do the machinations with a and b, as we discussed for the ellipse, it'll always be the case, if you do what we're doing right now, that b squared is equal to c squared minus a squared. And when I say it'll always be the case, this equation will hold whether the ellipse is left, right, or if it's up or down. Okay, so if I'm moving on here, what else do I have? I've learned that one vertex is here at the point 3, 0. Okay, so I can draw this thing now. Here it goes, here it goes, here it goes, here it goes, and you didn't see it, but indeed I drew in these asymptotes. This asymptote is y is equal to a over b. Well, let me go ahead and find a and b for us, and then we'll draw that in after the fact. Okay. Now I drew it like this because I'm given two vertices, 5, 0, minus 5, 0. The center is midway between those two, and my cat is about ready to step on this, and she moved away. So 5, 0, minus 5, 0, the center is midway between the two. So in this case, this is a hyperbola centered on the origin, in which case I'm looking exactly at this relationship, origin, center at the origin. And I can read off then that the focal lengths, the distance from the origin to the focal point, is 5. Yeah. Likewise, this A is always the distance center to the vertex. So A is equal to 3. I sense a Pythagorean triplet again. Okay, and indeed, if I come down here and search for B squared has got to be C squared, 25, minus A squared, 9, is equal to 16. B has got to be equal to 4. Okay, now I can come up here and say, well, this is y is equal to b over a, 4/3 x. This is y is equal to minus 4/3 x. And those are the two lines which are cut through the origin. One has a slope of 3/4, one has a slope of minus 3/4, and the hyperbola is asymptotic to these lines. Yeah. So all I have to do is put this data in. I'm going to get x squared all over a squared minus y squared all over b squared is equal to 1. And I believe that's all that this problem wanted. 669, 23. Find an equation, draw the graph. Okay, move on.